In this video, we're going to show a sneak peek of graphical reporting for one-way shear for beams and one-way slabs in Adapt Builder. This will be available in Adapt Builder 2020, and we're going to walk through just the different features that are going to be available for the user and show what current features there are so we can get a comparative view of some of the new enhancements. Okay, so we'll go ahead now and just open the program. And we're going to use an RC system here for the example. We'll be using Floor Pro. This allows us to model elevated slabs and beams. And we can turn edge off. We'll use US unit system for this example. We're going to set this up similar to what we might have for a parking structure. So I'm going to use a grid. And in the X direction, we're going to say the base spacing will be 25 feet. In the Y direction, I'll just say 55 feet. We have something like this, and we'll go ahead under model, just put in a few columns here. So I'll make these columns 24 by 24 square. I'll do a 3-span condition, and then between the columns we're going to have, let's say, a 22 by 36 inch deep beam. And this applies to either post-tensioned or RC beams in the program. Again, we're using just RC mode here, but if we wanted to, we could have added post-tensioning into these members as well had we opened the program in RC and PT mode. So I'm going to take this and just copy it multiple times onto these grid lines, so something like so. I'll turn off the grids, and then we're going to add a 6-inch slab here, so I'll change the properties of the slab maybe to 6 inches, and then I'm going to snap over to this corner of a column. If I use snap to vertices, I'm able to easily do that, and I'll just go ahead and build the slab. So this is our 6-inch slab on our beams. I can backspace to undo if I miss snap one of the points there. And just to confirm the geometry, we can go to visibility, and I can use the section cut tool and just take a cut through, and this is our one-way slab cut. If I cut through the columns, for example, then I have something like that. So these look okay. I'm also going to model just some beams along the column lines in this direction. So let's turn off the snap to vertices, and I can just snap to the endpoints of the beams. If I go into continuous mode, then I don't have to snap the start point each time. I can just do something like that, and then we'll come back. We stay in continuous mode until we go back and we turn that mode off from the beam modeling tool. So I can turn that off here. Okay, now that we have our slab built, we're going to model. We're really going to look at just a couple of these beam lines here in the Y direction, so the main beams carrying the one-way slab. And what we'll do is let's just add some load here. We'll go to loading. I'm going to use patch load wizard. For the dead load, I'll add 10 psf, and for the live load, we're going to add 40 psf. Okay, we have our loading. If I look at a 3D view, we can see the loading there. And then finally, we're going to add some design strips. So I'm going to go to floor design. I'll select the Y direction, and one other thing that's coming in the 2020 version is this property grid. I could go to criteria and just change this immediately here to beam, and that allows me then to make the modification without going into the properties dialog window that's used in the current version of the software. So this is also something that will make life easier for users, being able to quickly make modifications to components in that environment versus property windows for selected components. So each of these should be set to beam, and you can see if I double click on that to go into the properties, we can see the design criteria for this support line should be set to beam, which it is. In addition to that, if I select this, I could also choose whether or not to use, for example, effective width for the design of the beam. Right now we can see that the width here, if I select that again, very auto, You can do user define. This actually allows the user to input a width on either side, or I can go here under the properties for the design section options and say use effective width for this beam. So those are just a few other options that are available in the program currently in the current commercial 2019 version. So once I generate my support lines, I'm going to generate my design cuts. And you can see here the program actually limited this tributary to either side to 3 feet per the setting I had just made. So if I come back here, this is actually set to max width per side at 3 feet. That's a user definition. I'll do auto and just come back and reselect that and regenerate, and that changes that back to full flange width for the tributary. All right, under floor design, under shear design, we can set our stirrups. So here we have stirrups normal to the member. We're going to use 2 legs. Number of legs is 2. We can also set the stirrup size. If we go to rebar size and material, we have the ability here for beam criteria to set this maybe to number 4 bars, and then assign the material to that particular type of reinforcement. Alright, so we're going to go ahead now and mesh the slab. And after we mesh, we'll analyze. I'm just going to analyze for one of the strength combinations just to show this. Actually, I'll do both strength combinations. And so for strength combination types, we're actually designing the reinforcement for one-way shear. So it's important for the user to make sure those analysis and design types are specified for the load combination and actually analyzed when we run the model. We've analyzed this. I'm going to go back to my default display to kind of clean the screen there, and I will design the sections now. This is going to design each of the different strips that I identified along these beam paths. So if we go to the display of the strips, I'll turn on the Y direction strips. I'll actually turn off the design cuts, and we can see actions. For example, for strength dead and live, which I select under the load combination input tab, we can review actions. For example, I want to look at the shear diagram, and this allows me to show that shear diagram. This diagram is flattened. This is not in-plane shear, it's vertical shear in the Z direction out of the screen. We just flatten and kind of pancake the diagram on the screen. So if I wanted to actually show this in 3 dimensions in the Z direction, I can use this vertical or perpendicular projection, and I can rotate this to see these shear diagrams along the beams. So the program is designing now for these diagrams. Now the new things that are coming in 2020 as it relates to shear, I'm going to show you in just a moment, but currently it can be a little bit tedious to get the shear reinforcement out of the program, and to do that, there's really 3 ways to do that. One is through a tabular report. So if we go to reports and we go to design strips, design section rebar, this includes both flexural and shear reinforcement. So if I was to launch this report, let's say for strength dead and live, the program is going to open a Word document. It's an RTF document, rich text formatted report, and it's going to essentially show each of the design cuts. So this design section is for some support line in the model. This is for support line 1, and this will show me for each design cut. In this case, there are several cuts per span. The program will show me the area of shear requirement per foot and the stirrup spacing. Okay, so this takes some relation back to the model, so I have to know where the support line is, where the design cut is, in order to relationally see that in the actual graphical model. And we could do that. We could turn on the design strips. I can go back to floor design, turn on these design strips. I can turn on the labels of the design strips under this option here for visibility view settings, and we can turn on the label here. So that it takes a little more work to see exactly what's required in what location. Another option would be to select the strip. Let me go back and just flatten that shear graph. So if I select this strip, I can produce an elevation of this 3-span condition, and I can put that here. This shows me the shear reinforcement along each span. And it actually gives me indication. The asterisks mean the stress has been exceeded, the allowable maximum shear stress. And then it actually goes into showing a graphical representation of the reinforcements. We have 22 stirrups at 4 inches on center, and that's space. The total length there is 7.87 feet, and it goes into each unique set of stirrups. So this is pretty useful for reinforcement. If I calculate the actual flexural rebar as well, and I come back and reproduce that image, you can see that's actually going to show me not only the stirrups but also the flexural reinforcement in the member. So that's the second option. The third option is more of a summary. We can use what's called builder sum. I can select, double click the strip again, go to this builder sum tab, which is a separate module that produces graphical results for support lines. So for the envelope, if I use this summary report, I can see some summarized view of the shear stirrups with these graphical views. So this is a little bit harder to locate the reference point of the shear stirrups and to get exact figures along the span, but it at least shows kind of the clustering and the density for the requirement of shear reinforcement. So those are the three ways, just to summarize, that are currently available in the software, and some of those might be more useful than others. But what we've done is we've added, let me go back to my default display, and I'll turn on my strips again without the section cuts, and we've actually added this option here in this result tree. We call this result display settings, informally called the result browser. But if I collapse this and I come back to design sections, we now have both reinforcement, longitudinal, flexural reinforcement graphs, and that shows me, for example, calculated reinforcement on a graph. The blue is positive reinforcement in area of steel. This is for strength dead and live. This is the area of steel required at these different design cuts. The green is the negative reinforcement or top reinforcement, and so on. So we do this for reinforcement, for flexural reinforcement, but we also now have introduced this for one-way shear. So the first thing we can do is show a shear stress check. Okay, and this shear stress check just gives some color coding, or will provide color coding as to the status of that location. I have to have my sections turned on. Pink means we exceed code, so here we exceed code in these areas just away from the support, maximum shear in this case. We're okay in the center of span, that makes sense, and between those two locations we need reinforcement. So this just gives us an overall perspective of the status of the design. The next option will show us the concrete shear strength. So this is the FVC. This was without stirrups. And so for every design cut, we can see exactly what the capacity is for that section. And here this is all flat. I mean, all these capacities are the same. Everything is symmetric, the same size. 23.31 kips for concrete shear capacity. If I want to look at the ratio, VU over FVC, this gives me the ratio. It gives me a max min. This clearly shows me where that ratio gets really high near the supports. That's where we're exceeding code, and then it starts to drop down. We need reinforcement really greater than anything greater than 0.5. Between 0.5 and 1, we would need minimum reinforcement. Greater than 1, we would need reinforcement by calculation. And so this is a nice graphic to where we can kind of see a relative view of our max shear over each of the different beam spans. The next option will show the required shear reinforcement. So this is really in, this would be inches squared per foot. Okay, so at these different sections, we know that along this strip, we said the spacing is 2 feet. So you can use the spacing to your advantage here. And so we know between these two sections, or between here and here, we need 2.52 square inches per 2 feet, roughly 1.25 per foot. So based on your spacing, you can use that to kind of normalize the shear based on some unit spacing that you enter there for the design cuts. And this just gives us the area of reinforcement for each of the different sections. where you exceed code, we have these gaps really in the beams where we exceed code. The program is really not even designing reinforcement because this requires some either material or geometric manipulation in order for the code to not be exceeded. So this may require the beam to be deepened or the concrete compressive strength to be increased. Maybe both of those variables need to change, but this is what that's indicating through here, and that kind of happens on these two internal supports, and even the external supports, that's happening as well. The next thing is what's provided. This is the shear reinforcement provided. So you can see, for example, we needed 2.52. The provided reinforcement is actually 2.54, and that's just a function of the area of steel based on the size of reinforcement we're using. And then finally, we can look at shear stirrups. So the program will show us on each of the beams, it just flattens this, it shows us the reinforcement layout. Again, from this point out to here, we have exceeds code, and then we get into that same kind of layout view that we saw kind of in elevation earlier, but now we're just flattening it on the actual member itself. This makes it a little bit easier because now I can actually dimension this view. I can say, well, I need to know exactly kind of where that exceeds code range is, and I can use my dimensioning tool to kind of do that. So I can do something, let me try that again, something in here. I'll go from this point maybe to there, right? That's about 11 feet is that zone. So use the dimension tool in conjunction. This can all be exported as a DWG. We can export this here using this report option to export to CAD. But this allows us to give more information for one-way shear in the program. This will be available in version 2020. If you have any questions or feedback, please let us know. adaptsupport@risa.com. Thank you.